Hello, welcome to Emmanuel Maths Academy. So today we'll be looking at differentiation of exponential functions, right? Now, if you are given a function f of x equal to y, let's say we are given exponential x, then the derivative of this is that you can use two methods. You can use direct differentiation, make use of the knowledge of implicit differentiation, or you can make use of series expansion, right? Let's make use of series expansion first. Then we say that in series expansion that exponential x is equal to 1 plus x power 2 over 2 factorial plus x power 3 over 3 factorial plus x power 4 over 4 factorial plus, and it continues, right? Now, if y is equal to this, let's say y is equal to this. To differentiate this, you now have that our dy dx is equal to, if you differentiate this constant, you get 0. Differentiate this, you get 1. Plus, if you differentiate this, this will multiply this, and you subtract 1. You have 2x over 2 factorial plus 3x power 2 over 3 factorial plus 4x power 4 over 4 factorial. Then it continues, right? Now from this, recall that in your factorial, that the factorial of a number is the multiplication of that number of the consecutive terms in descending order till you get 1. Look at what I mean. 2 factorial is equal to 2 times 1, right? Then 3 factorial is equal to 3 times 2 times 1. 4 factorial is equal to 4 times 3 times 2 times 1, right? Then likewise 5 factorial. This is equal to 5 times 4 times 3 times 2 times 1. As simple as that, right? From this, you can say that you can actually manipulate this to get that our 5 factorial is equal to 5 times 4 factorial, right? Because this 4 factorial is from this to this, right? From here to here is 4 factorial, which is this. You can say that 5 factorial is 5 times 4 factorial, and likewise 4 factorial. You can say that 4 factorial is 4 times 3 factorial. Is that clear? Because if you have 4 factorial, have 4 times 3. 3 factorial is this we have here, and this is the same thing as this. You can see that 4 factorial is 4 times 3 factorial. Is that clear? Now from this, you have that our dy dx is equal to 1 plus 2x over 2 times 1 plus 3x power 2 over 3 times 2 factorial plus 4x power 4 over 4 times 3. No, this should be 3. Sorry. Because if you subtract 1, you have, this should be 3, please. This should be 3. 3 factorial plus, right? Then if this will cancel this, 3 will cancel 3, this will cancel this. You now have that our dy dx is equal to 1 plus x power 2 over 2 factorial plus x power 3 over 3 factorial, right? You can see that this whole thing is equal to what we have here. And what you have here is what? Exponential x, right? That means the derivative of exponential x will also give you exponential x. When you differentiate exponential x, you get exponential x, right? You can also use direct differentiation using make use of implicit differentiation or implicit differentiation method, right? Look at what I mean. If you are given now y is equal to exponential x, to differentiate this, if you take the lane of the both side, you have solution. If you take the lane of the both side, you have lane y over lane exponential x, right? You now have ln y equal to x, because ln will cancel exponential. If you differentiate this implicitly, using implicit differentiation, you have 1 over y dy dx equal to 1. You now cross multiply, making dy dx the solution formula. You have dy dx equal to y. And what's our y? Recall that y is equal to exponential x. That means, hence, therefore, dy dx is equal to exponential x. Right? As simple as that. As simple as that. Now let's look at this example. What if you are given y equal to exponential 2x? How do we go about this? What we do is you let a letter u to be this. Just you apply the knowledge of chain rule, right? You say let u equal to 2x. Automatically our y will now be exponential u. Now make use of the knowledge of chain rule. Now have that our du dx is equal to 2 and dy du is equal to exponential u, because if you differentiate exponential x, you get exponential x. Likewise, if you differentiate exponential u, you get exponential u. Is that clear? Then the chain rule says that dy dx is equal to dy du dot du over dx. Now this is equal to what? Our dy du is what? What's our dy du? Our dy du is this. You have exponential u dot what? 2. Right? But recall that our u is what? Our u is 2x. Now substitute the value of u for this 2x. You now have that our dy dx is equal to 2 exponential 2x. As simple as that. Now let's look at another example. If you are given, let's say you are given y equal to x squared exponential 3x. To find your derivative, you apply product rule, because this is multiplying this, right? If this is multiplying this, you apply product rule. Then when you differentiate this side, which is our v, because this is our u, this is our v, then you now apply the chain rule, right? This is just actually simple. What you do is you multiply this with the derivative of what you have here. As simple as that. Now take a look. We say that solution at dy dx in product rule is keep u differentiate v with respect to x plus keep v differentiate u with respect to x. Is that clear? Now keeping this u with respect, differentiating this v with respect to x, you now have x squared dot 3 exponential 3x, right? Plus keep this, differentiate this, you have 2x. Is that clear? Now, hence our dy dx is equal to 3x power 2 exponential 3x plus 2x exponential 3x. Right? You can even you can actually factorize something out. You can factorize x exponential 3x. If you factorize x exponential 3x out, wait, this is your answer. You can leave it this way, or you can decide to factorize, which will give you dy dx equal to x exponential 3x to bracket 3x plus 2. As simple as that. You can decide to leave your answer this way, or you factorize to get this. As simple as that.